In this chapter, we are going to first work with what's called a system of linear equations. And all that means is that we have a set of linear equations, aka we have some lines. You are not using an expo marker to take notes. Try again.
One thing. I use
No. Now, based on our warm-up activity, the solution to the system of linear equations is where? Okay. So technically, our solution is a point that satisfies each equation. What does that mean? I can plug the x in to both of them and get the same y. Okay. That is occurring wherever we intersect. Do you have a question? Corey?
Oh, no.
Okay. So this is what's going to happen. We are going to solve systems of linear equations by graphing them. Okay. Now, first, I want to show you. We're going to kind of go back and forth on our page here. I want you to go to the next page and I want you to look at number 1. Okay. So in number 1, they're saying, hey, is 3, 1 the solution to this system of linear equations? If it's a solution, what should happen?
It should equal out to the answer.
Okay, we should be able to plug it in and it works, right? So if we plug 3, 1 into this first equation that I'm highlighting in blue, x plus y equals 4. Is that true?
Yes.
Okay. Now this second one in red, 2x minus y equals 3. Okay. So this is not a solution because it has to work in both. Okay. Now what we are going to do, we are going to find our solutions and we're going to double check our work by making sure it plugs into both and we get the same thing. Okay. So previous page. I'm going to give you 2 lines and you are going to graph each of them in the same coordinate plane. Okay, we get a graph. Then, can you cross out the word estimate? Estimate. We are not going to estimate. We are going to actually find the point of intersection. Okay. And then we are going to check by plugging in just to make sure it does, in fact, work for both. Okay. It's a really good thing. We just practiced graphing lines for a couple chapters, huh? What?
I don't remember my own.
You literally just did it.
I don't know if he's saying that to get under my skin
No, I
or
literally don't. I think.
like you literally just took a test yesterday.
Well, yeah, no, it's-
Yeah, you don't remember. Okay, so go to number 7 on this next page. Okay, here the lines are already graphed. Our answer is where they intersect. Where is that happening? Okay. So our answer would be 2 comma negative 2 as long as we double check, right? 3x minus 2y, does that equal 10?
Yeah.
Because we'd get 6 plus 4, right? Okay. X plus y, does that equal 0? Okay, so our answer is good to go.
If we were to say intersecting, why would we have to?
So, couple things. Make sure you counted right. But especially when we're graphing, if you're not drawing a super straight line, it could be a problem. Because lines are straight.
Wait, what?
My line is straight.
Okay, go to the next page. All right, let's graph these 2 lines. So let's talk about line pink. Where am I going to start with line pink? Our our y-intercept, excuse me, is 3. Kyron, what's our slope?
-1/1.
Okay, so we need to make sure that we have a negative slope. If I were you, I would use the straight edge to draw my line.
So on my fingers,
I know there was one. Why are my fingers? Which one side? Which one side?
Okay, now line orange. What's our y-intercept? 5. You guys, nobody corrected me. Nothing?
What about it?
Nothing.
I said I did.
I'm fine. I thought I made a mistake, but I didn't. Okay, thank
I
you.
said that.
What's our slope?
It's 1, but the thing, the jig, -1,4.
Okay, so I have a question. If I count my slope, would my orange line have a point here?
Yes.
Well, that's convenient. Okay. So Kyron is saying, hey, is our point of intersection -1, 4? Okay, well, let's check our answer. Is -1 plus 3 equal to our y of 4?
Yeah.
Okay, is -1 plus 5 equal to our y of 4?
Yeah.
Awesome. That's really awesome. How about you graph number 11 for me? You are graphing number 11 for me. You might find it helpful to count slope for more than a couple points to make sure that you are getting that correct intersection. Ask your neighbor if they have the same intersection as you.
I messed it up.
Come on.
Oh, wait, no, I did it right.
Three.
Two comma
Tree. Yeah.
We had a wall of brownies, but we did not want.
Really a ball,
Okay, so it really seems like you guys graphed these super quick. Noah, what's your intersection? Did you check it? Yeah, he says. Okay, is 1/2 times 2 plus 2 equal to 3?
Yeah.
Is negative 1/2 times 2 plus 4 equal to 3?
Yeah.
Okay, great. I want to go through number 12. Oh.
Really?
Well, does it have an X?
Well, but it doesn't
Okay.
give us a Y intercept.
It's not.
So here's the deal, guys. We have more than one way to graph a line. Let's talk about this second one first. With your arm, show me what that looks like.
Oh, wait.
This way.
Diagonal.
What?
You said they're not diagonal.
That's our line y equals negative 3. Now, you have two options here. Yes, you can solve for y and put this into slope-intercept form. Or or you can graph using the intercept method. If we plug 0 in for x, what would our y-intercept be? Really? And x, if we plug x in, 0 in for y, what's our x-intercept? Huh? Try again. Are you even looking at what I'm doing? 3x minus 2 times 0 equals 6. 3x equals 6. So x equals 2. So I have my y and x intercept that I can graph and connect the dots. Like that was a strategy that we had, guys.
I remember doing this, like, I don't remember.
So now we know that our intersection point is 0, negative 3.
Wait, but if you put that in, it doesn't have to.
Eli, don't say anything, because he's not doing anything.
No.
So if you put in 0 for X and -3 for Y, you don't get 6? Okay. Okay, DJ. Because this point right here from the origin, I didn't have to move right or left. I just went down. So this coordinate right here where they intersect is 0, -3. Now, this right here is, why are people talking while I am? Oh, don't pretend that you weren't talking right before her. This work in blue were to get these two coordinates for my X and Y intercepts to connect them to get that blue line. Okay, it just so happened that one of those points was also our intersection point. Okay, yeah.
If that's to graph and they don't use
So let's talk about that. If they were not going to intersect, what would have to be true about your lines? If your two lines were parallel, they would not intersect, and we would not have a point of intersection. We'll do more with that after Thanksgiving. But for now, I will give you two lines